Pre-calculus, Chapter 4, Lesson 4, and we want to begin or continue looking at these trigonometric functions, and now we want to look at their graphs. Before we take a look at their graphs, let's review a little bit of what we talked about and then talk about where these graphs come from and what they're actually a graph of, and then we'll take a look at their equations and stretches and shrinks and that kind of stuff. So let's begin by, again, going back to our unit circle. So this circle has a radius of 1, so we talked about this coordinate then being the coordinate 1, 0, and so that would make this coordinate 0, 1. The coordinate of this point would be negative 1, 0, and this coordinate here would be 0, negative 1. And if we talked about the measure of these angles, or what these angles would be as we rotate from this initial side of the x-axis, this is going to be the pi over 2 angle, or 90 degrees. This angle here is going to be pi, or 180. This angle here is going to be 3 pi over 2, or 3 pi over 2 angles, 3 90-degree angles. And then once around the circle would be 2 pi. Okay, and you remember we talked about, because this radius is 1, that we can actually very quickly then associate this coordinate here with the cosine, because the cosine is the x over the r, and because r is 1, it simply is x over 1, or the x value. So this x value is actually the cosine of 2 pi, or the cosine of 0, because this is also the 0-degree angle. And the sine is 0. And then as we get up to pi over 2, this is the cosine, and the y value is the sine. As we get over to pi, this is the cosine, the negative at 1, or the x value, and this sine value is 0. And at 3 pi over 2, the x value is 0, so the cosine associated with that is 0, and the sine is negative 1. And we talked about, because this radius is 1, then anywhere we go on this circle, the x value of this point right here is the cosine of that angle, and the y value of this point is the sine value of that angle, whatever it may be. And no matter where I go on the circle, that's going to be true, because the r value in every instance is 1. And so when we take x over 1, we simply get the x. If we take the y over 1, we simply get the y. Okay, so that kind of ties together what we've been doing. So let's take a look then at the sine graph, or what it looks like then, or what is the sine graph a picture of. Okay, so let me think. I have a website up here that we want to look at. Here we go. Okay, so here's the angle at 0, the initial side, and as this point moves around the circle, okay, you'll see that we're plotting the angle measure here changes from 0 up to 90 degrees, which would be right here, and then pi, you remember, is half a circle, or 180, that's 3.14, and then here is 3 pi over 2, which is that angle there, and then 2 pi, or once around the circle, would be here. So our x values are the angle measurements. And remember, we talked about degree not being any kind of relationship for us, but if we're in radian measure, then we have this relationship, which we're able to do. So the x values along the x-axis are the angle measurements. Those are the inputs. So then what are these y? What are these outputs? What are these y values? Well, remember, the sine graph, or the sine function, is related to the y values as you move around the circle. So what this is a picture of is all of the different y values that are possible on this circle, on this unit circle, as you go around with different angle measurements. So as we get to pi over 2, or 90 degrees, the sine value is up here. As we get to over here, the sine value is what the x value is at 180, and at 270, the y value at 270, and then as you get around the circle, the y value back at 2 pi. So the sine function is a plotting of the y values, those are the outputs, of this coordinate as it moves around this unit circle, the x values being the angles, or the inputs. Okay, so again, we're relating the sine function to the y values. and the cosine functions to the x values. So the sine function, this picture, which you see, is a picture of all of the different y values that are associated with these different angle measurements. So once again, the angle measure is the input. The y value, or the sine value, is the output. And you'll notice that, as we've talked about, this pattern is simply going to repeat, because as you go around the circle, the y values repeat. You have the y values go up, they go down, and then they come back to the beginning point, and then when you go around the circle, they simply repeat. So this sine function continues repeating itself all the way out infinitely this way, and if we were able to turn this make this function go clockwise or negative, then over in the negative side it would complete the same pattern. So this is a picture of the sine function, and the sine function is a tracking or a plotting of the y values on the unit circle as the angle measures begin at 0 and then rotate around the circle. So if the sine values are the y values, what do you think the cosine function is? Well, the cosine would be a tracking of the x values. So if we start at the x values and we go around the circle, then we have, these are all of the different x values as this point moves around the circle, again, as these angle measurements are put in. So as the angle measurements change from 0 and move around the circle, what happens to the x values? So you can see the x values are plotted here, and that's a picture of the cosine. Okay, now I don't know why this particular website has the beginning of the cosine function with up here. That's the positive x-axis. It should be turned. I don't know why it's like that. It might be just because my Java's maybe not up to date or something. But we'll take a look at this in just a moment. So the cosine function related to the x values, therefore what we have here is a picture of all of the different x values of that coordinate, of that point, as it moves around the circle as the angle measures change. So let me go back to our graph and kind of give you an overview of what's happening then. I want you to look at let's look at the sine function, okay, really quickly. Now at 0, what is the sine function value? It's 0. Now what happens at pi over 2 or 90 degrees? It's at 1. So from 0 up to here, what's happening to the y value? It's getting larger. It's going from 0, which it is here, to 1. And again, if you think about this y-axis, as this point moves around the circle, it's moving higher and higher, and so the y value is getting bigger and bigger, up to a maximum of 1. As it continues around, the y value starts to fall now. It starts to come down as it goes around the circle, and it gets back down to 1. I'm sorry, to 0. Now it continues to fall until it gets down to -1. The y value drops to -1, and then as you move up, the y value now begins to increase again as it moves around the circle, and it increases back to 0 and gets up to a maximum of 1, and then it begins to fall all the way down to -1. So the y values begin at 0, they increase to a maximum at 1. They then decrease to a maximum or a minimum here, or goes back to 0 here, goes down to a minimum of -1, and then comes back to 0. Now, there's 4 very important points where all of this happens. It begins at 0, at pi over 2, at pi, at 3 pi over 2, and at 2 pi. So at the quadrantal angles is where the sine function begins to make its changes. It starts at 0, it goes to a maximum at 1. At that quadrantal angle, it begins to fall and gets back to 0. From there, it goes at the next quadrantal angle, it reaches its minimum, and then at the next quadrantal angle, it's back at 0. Okay, so the sine function then begins at 0. Okay, it then gets to its maximum point at 1. It then goes back to 0, it gets down to its minimum point, and then it gets back to 0. And this is at angle 0. It reaches its maximum at pi over 2. It gets back to 0 at pi. It reaches its minimum at 3 pi over 2, and then it gets back to its 0 at 2 pi. Okay? So just kind of keep that in mind. If we look at the cosine then, the cosine, you'll notice, begins at 1. And then it begins to fall, and these are the x values. So again, as you're going around the circle, the x values begin to go back towards 0. So they begin at a maximum of 1, it gets back to 0, and then as you go here, the x values continue to fall or continue to go towards negative, down to -1. That's the smallest they get, and then at this point, as it goes around the circle, the x values begin to climb back up as it moves along the x-axis this way. So the x values begin to climb, they get back to 0 here, continue to climb to a maximum of 1. So the cosine function begins at its maximum. So it begins at its maximum at 0. It then gets to 0 at pi over 2. It reaches its minimum value at pi. It gets back to 0 at 3 pi over 2, and then gets back to its maximum point when it gets around to 2 pi. Okay? So I'm going to kind of tie this video up right here. That kind of begins our discussion, and then we're going to get back to these when we actually looked at the graph. So these are very important things that I want you to kind of get out of this video, is that the sine function begins at 0. The cosine function begins at its maximum point. And then it always goes through this progression. Sine starts at 0, goes to max, back to 0, down to min, back to 0. 0, maximum, 0, minimum, 0. The cosine function begins at maximum and then goes to 0, down to minimum, back to 0, back to its maximum. Okay, so it always begins at its maximum. So this is the key point. Cosines begin at their max, sine begins at 0, and then they go through their progression going from 0 to max to 0 to min to 0. And cosine, max to 0, min to 0, max to 0, min to 0, etc., etc. Okay, so we'll tie those together, and then we'll look at the graph real quick. We'll show you how you can graph those, and then we'll look at the stretches and strengths in the coming lessons.